Hello, my name is Todd. I'm going to be your logic tutor today. This is part 2 of calculating truth tables and statement classification. All right, up until now we've worked with statements that have had just two statement constants. Notice in this problem right here, we've got hi and j, so we have three statement constants. So if we want to figure out how many lines we're going to need, how many possible interpretations there are of this statement, it's 2 to the third, which is 2 times 2 times 2, which is 8. So we have 8 lines so that we can come up with all the possible combinations of truth values for the statement constants hi and j. Recall the way that you fill the chart in to get all the possible combinations is start with the rightmost statement constant and just rotate between the truth values of true and false all the way down until you run out of lines. As you move over, so I'm moving over to the left, I'm going to double the pattern, so it's 2 truths followed by 2 falses, and then I'm just going to repeat the pattern. Okay, now as we move over one more, we are going to double the pattern again. So we'll have 4 truths followed by 4 false. And if we follow that pattern, we will have created all the possible combinations of truth values for hi and j. Now we just need to calculate the truth value for this big expression for each one of all of these different interpretations. Okay. Remember, in general, we work from inside the brackets out, and I'm going to start with this part of the problem over here because I have a negation that I can get rid of pretty quickly. Notice I have to calculate not h. So let me just copy the values from the h column and put them under the h, and that would be true, 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 false, 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 and false. Now, these values are going to be negated, so I end up with false, 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 true, 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 and true. So this column right here represents not h, and so let me get rid of this so I don't get confused. We're going to eventually OR that result with this over here, but we need to calculate the I then j. Let me begin by writing in the values for I, so I'm just copying the I column over here, true, true, false, false, true, true, false, false, and I'll copy the j column, which rotates between true and false. Now, I don't have to copy these over here. I could just look over and then calculate the result, but by actually writing them under the statement constants, I'm less likely to make a mistake looking back and forth. All right, so let's calculate the truth value of I then j for line 1 when I is true and j is true. That would be true, and you would find that. You look down here and look here, and you see it's true. Similarly, on line 2, I is true, j is false, so the antecedent is true, the consequent is false. That's this case right here, and we see it's false. Okay, so I'm getting my answers for the if-then based on that basic truth table down here. All right, to continue, this would be true, this would be true, this would be true, this one would be false, this one would be true, and this one would be true. All right, and let me get rid of these since I've used them. So now what I need to do is take this result and perform the OR operation. If I do, I get true, false, true, 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 and true. So, for example, on line 1, the left disjunct is false and the right one is true. That would be this case right down here, case 3. The first part is false, second part is true, and since it's the disjunction, I look over here and I see, oh, the value is true. All right, so let me cross out the columns that I've used so I don't confuse myself. So what's left is this column right here. This is the result of the right side of the biconditional. All right, so let's do the left side of the biconditional. The first thing we need to do is calculate this I then j business, and we can do that again by first writing down the values for I, true, true, false, false, true, true, false, false, and the values for j, which are true, false, true, false, true, false, true, false. And now doing the if-then operation, I get true, false, true, 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 false, true, and true. And I'm going to scratch these out since I'm only concerned now with the result. And I'm going to take this result and I'm going to do an if-then with the h. But let me write down the h first. The h, I'm just copying this column over here. True, 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 false, 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 and false. So I'm going to do an if-then operation now, and I get true, false, true, 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 and true. So let me cross out the ones that I used, and my result for the left-hand side of the biconditional is this column right under the horseshoe. So I need to take that result, this one right here, and this result right here, and do the if and only if operation. So on line 1, I have a true, if and only if, true, which is true. Sorry, I'm getting a bit messy here. Line 2, I have a false, if and only if, false, which is true. Line 3, I have a true, if and only if true, which is true. Line 4, true, if and only if true, which is true. 5 is true, if and only if true, which is true. 6 is true, if and only if true, which is true. 7 is true, if and only if true, which is true. And 8 is true, if and only if true, which is true. So notice again, the final column always came out true for every possible interpretation, and so we would call that sort of statement a tautology. All right, let's move on and do one more. And how about this one right here? Again, three-statement constant, so 2 to the third equals 8, so we need 8 lines to come up with all the possible combinations of truth values for the statement constants. Begin over here to fill in the values: true, false, true, false, true, false, true, false, and M. We double the pattern when we move over, so it's true, true, false, false, true, true, false, false. And as we move over to the last statement constant, we double the pattern again. So we would have 4 trues followed by 4 false. All right. So that gives us all the possible combinations of truth values for the parts. Now we're going to figure out the truth value for the expression for every interpretation. First things first, I have to work from inside the brackets out, so I'm going to do this calculation, M or N. Let me write the M column down. That goes true, true, false, false, true, true, false, false. And the N column is true, false, true, false, true, false, true, false. And we're going to do an OR. Now I could do these very quickly because I have this memorized or understood completely, you can always refer back to it to see that my calculations are right. So, on 1, true or true is true, true or false is true, false or true is true, false or false is false, true or true is true, true or false is true, false or true is true, false or false is false. So that's the result for M or N. I need to OR that with L. Let me write in the value of L, true, 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 false, false, and false. I'm just copying that column over there. Now I'm going to do an OR. I'm going to true or true is true. Line 2, we have true and true, that's true. Line 3, true or true is true. Line 4, true or false is true. Line 5, false or true is true. Line 6, false or true is true. 7, false or true is true. And line 8, false or false is false. So we nearly had all trues, in which case it would have been a tautology. But we have at least one true and at least one false, and in that case we say the statement is contingent. Oops, let me move over. Contingent. If a statement has at least one interpretation when it's true and one interpretation when it's false, we say it's contingent. Now, one thing that we hadn't done is a statement that always turned out false. If we have a statement that always turns out false, we say it's self-contradictory. Okay, and if we did a truth table for the simple statement, something like A and not A, that would always come out false, and we would say that statement is contradictory. All right, I think now you should be able to calculate truth values or truth tables for complex statements and classify the results as tautologies, contingent, or self